Hi, welcome to Unit 7, Day 5. This is example problem 1. Sorry, example problem 4. So in example problem 3, we use the same chemical reaction. So I already checked that this was balanced. So they're balanced with all coefficients of 1. So that's done. I also already calculated the molar masses of silver of the sodium chloride, the silver nitrate, and then the silver chloride. So in this problem, they're saying if we combine 1 gram of silver nitrate and excess sodium chloride, what is the theoretical yield of silver chloride? And then they tell us how much we actually get if we isolated 0.605 grams of silver chloride, then the axis for the percent yield. All right. So one thing you'll notice with this problem is that they only give us a mass for one of the reactants, only for the silver nitrate, but they tell us that we have excess NaCl. So what exactly do you think that means? That means we have less work, actually. So since the NaCl is in excess, it cannot be our limiting. So we already know what our limiting reactant is. So that's one of the reasons why it doesn't ask what's the limiting reactant, because we actually know it. It's whatever is not in excess, so that would be Agn03. So to get the theoretical yield, what we're going to do in this case is use our limiting reactant and find the amount of product that we can make from that limiting reactant. Now this reaction has 2 products, so we have to use the product that they're asking us for the theoretical yield of, and that is Agcl. So that's the product that we're going to focus on. So we actually only need to do one calculation for step 2, which is to go from the grams of Agn03 to the grams of Agcl. Okay, so I'm going to do this in a step-by-step fashion, and then I'll do it as a one line. I'll let you know when step-by-step is over, and then I'll link the one line at the appropriate place. Okay, so getting started here, we're starting with 1.00 grams of Agn03. And I want to go from, by the way, I should say, go from grams of Agn03 to moles of Agn03. That's my first sort of mini step. Okay, so from mass to the moles. So to go to the moles, I use the molar mass of Agn03, which is here 169.88 grams. Do you know why I put the grams of Agn03 on the bottom and the 1 mole on top? At this point, you should know that, because we've seen quite a few problems like that. So remember, so that the units of grams cancel out, since we don't want those units anymore. We want to try and get the moles. Okay, so my math here is 1 divided by 169.88, and then I get the moles to be 0.00589 moles of Agn03. All right. Step 2 is to go from moles of Agn03 to moles of Agcl. Now, this reaction has a 1-to-1 mole ratio, so I'm going to write it out, but actually, because it's a 1-to-1 mole ratio, the moles of Agcl will be equal to the moles of Agn03. All right, so if you have 1 mole of Agn03, then you can make 1 mole of Agcl. If you have 2 moles of Agn03, you can make 2 moles of Agcl. And if you have 0.00589 moles of Agn03, you can make 0.00589 moles of Agcl. So in terms of what the setup would look like, for those of you who are like, oh, I still want to see it, this is what it will look like. You take that answer there, put it over 1, just to make that into a fraction. And then 1 mole of Agn03 goes on the bottom, and then 1 mole of Agcl goes on top. And remember, these ones come from the coefficients in the balanced chemical equation. So those numbers, big numbers in front. Okay, so then that will be 0.00589 moles of Agcl. Okay, now that we have the moles of Agcl, we're going to go from moles of Agcl to grams of Agcl. And so in this case, we would take 0.00589 moles AgCl, put it over 1. And then over here, we would get the molar mass, which is 143.22. So what do you think goes in the bottom, the 1 mole of AgCl or the 143.22 grams of AgCl? If you said 1 mole of AgCl, you would be correct. So those units cancel out. And then the 143.22 grams of AgCl go on top. So I'm just multiplying these two numbers together to get my answer, 143.22. And that will give me 0.843 grams of AgCl. So that's my theoretical yield. Now to do my percent yield, I would take the actual amount that they tell me. They tell me I isolated 0.605 grams. Divided by my theoretical, so it's actual divided by theoretical. And 71.8%, which is okay, I guess. All right, so that's my percent yield. So this is how much of the product I actually made. Okay, that's it for the step-by-step. Now we're going to move on to the one-line process. All right, so for this problem, they tell us that if we combine 1 gram of AgNO3 with excess NaCl, what is the theoretical yield of AgCl? So notice how in this problem they only give us the mass of 1 reactant, not 2. They tell us that one's in excess and the other's a gram. So what does that mean? That means less work for us, because since they told us that the NaCl is in excess, that means that AgNO3 is the limiting, right? So notice that this problem doesn't even ask us what the limiting reactant is, because they already told us that by telling us NaCl is in excess, so the other thing must be our limiting. So AgNO3 is our limiting reactant. So what we're going to do is we're only going to use this reactant to find the amount of product it can make. Now remember, this reaction has 2 products, so the product that we're going to use will be the one that they're asking us to find the theoretical yield of, which is AgCl. All right, so what we're only having to do is go from the mass of AgNO3 to the mass of AgCl. So that makes our life so much easier when they give us that problem. So from grams of AgNO3 to grams of AgCl. All right, so we're going to start with 1.00 grams of AgNO3. Now I want to get to convert from the grams of AgNO3 to its moles. So from grams to moles, I need to use the molar mass, which I have up here. It's 169.88 grams. What do you think goes in the bottom here, the 169.88 grams or the 1 mole of AgNO3? 169.88 grams, because I'm trying to cancel out the grams here. All right. All right, so I've got my grams canceled out, and I have moles of AgNO3. Now I need to go from moles of AgNO3 to moles of my moles of AgCl. So for that, we look at the coefficients. Notice it's a 1-to-1 mole ratio, which makes it so much easier in terms of the math. Notice I put the moles of AgNO3 on the bottom, so they cancel out, leaving me with moles of AgCl. All right, last step is to go from moles of AgCl to the mass of AgCl, and for that we would use the molar mass. So here's the molar mass. So what do you think goes in the bottom here? Is it the 1 mole of AgCl or the 143.22 grams? You betcha it's the 1 mole of AgCl, so that those can cancel out, because I want to find the grams of it. And then 143.22 grams. Okay. All right, so when I multiply all of this out and do my math here for that, I get 0.8. I'll write it down here. Grams of Agcl. So that's my theoretical yield. Remember, I'm calculated this from the limiting reactant, so that's my theoretical yield. Okay. All right. Once I have my theoretical yield, in terms of the percent yield, I take the actual amount that I got, 6.605 grams. This is what I was told I isolated. So this is what I actually got from the reaction. And I divide it by the theoretical yield, which is like in theory what I could make. And then I multiply that by 100. And that's how I got the percent yield. All right, that's it for this video. Have a quality day.